Today we are going to see some important problems under Laplace transform of periodic functions. Okay, so yesterday we have discussed a problem. Now it's our second problem. The problem here is find the Laplace transform of modulus of sin t. They have simply given like this. Okay, they have not mentioned what is period. So we have to find that. So according to the Laplace transform of periodic functions, we know that L of f of t equal to 1 by 1 minus e power minus ps integral 0 to p e power of minus st f of t dt. So here p is the period such that p should be greater than 0. The period should be greater than 0. Okay, so p should be greater than 0. This condition is according to the definition of periodic function. Second condition is they have given modulus of f of t, that is modulus of sin t. So modulus of f of t means it will have two values. One is minus f of t and another one is plus f of t. Minus f of t is for t less than 0 and plus f of t for t greater than 0. So since they have given modulus, and as well as we know that the period p should be greater than 0, our f of t should be positive, so that we have to consider f of t for t greater than 0. We have to take this. That is first condition. So first of all, I shall split the given function f of t as f of t. What is f of t? F of t equal to, okay, I shall write here itself. F of t, that is equal to modulus of sin t, that is equal to, this modulus of sin t can be written as minus sin t for t less than 0 and plus sin t for t greater than 0. So in trigonometry, 0 is not the only value. So if t equal to 0, what will happen to sine? Sine will become 0. So always the trigonometric values lies within zeros and ones. Okay, so from zeros it will reach up to 1 and again it fall to 0. That is fundamentally happening in trigonometry, especially for sine, because we know that sine 0 0, sine pi 0, sine 2 pi is also 0, but sine 2 pi plus t equal to sin t. Sine 180 plus, this is sine 180, sine 360 plus theta is sin theta. Okay, so we have to be very specific about the intervals. So I am taking the intervals as f of t equal to modulus of sin t, that is equal to minus sin t for minus pi less than t less than 0 or sin t for 0 less than t less than pi, 0 less than t less than pi. So see, this t less than 0 is also now satisfied, this t greater than 0 is also now satisfied. Okay, so these are the limits. Okay, these are limits of, so between minus pi and 0 you will have minus pi by 2, and between 0 to pi you will have plus pi by 2, for which the values will exist. This is minus 180, minus 90, 0. This is 0, 90 and 180. So for which the values will become, sin t will become 1. Okay, now since they have given modulus of sin t, it is enough to consider only the positive value. It is enough only to consider positive value. Okay, so your solution should be, so these are for your understanding. Your solution should be f of t equal to modulus of sin t equal to minus sin t for minus pi less than t less than 0, sin t for 0 less than t less than pi, 0 less than t less than pi. Here you have to take, since sin t is positive, since sin t is positive in the second interval, sin t is positive in the second interval 0 comma pi, we have f of t as a periodic function, since sin t is positive in 0 comma pi, we have f of t as a, or we have f of t or we understand. Okay, if you put, we understand f of t is a periodic function with period, what is the period? Always final limit minus initial limit. So here we are not considering the first half. This is not going to be considered. Okay, so with period pi minus 0, so we will have the period pi, with period pi. Okay, so this understanding is very, very important to solve that problem. So after that the problem will be very, very simple. Because we know that now our f of t is simply sin t. Our f of t is simply sin t, because we have taken only the second set of interval value. Okay, so simply f of t is sin t. Now f of t equals sin t, and period p equal to pi. We know that L of f of t equal to 1 divided by 1 minus e power minus ps interval 0 to p e power of minus st f of t dt. So you will have L of they have given us modulus of sin t, but we are taking only sin t. So L of sin t, or you can take it as modulus of sin t, since they have given the question, equal to L of sine t equal to 1 by 1 minus e power of minus pi s integral 0 to pi s e power of minus st sine t dt. So here 1 by 1 minus e power of minus pi s can be taken outside, on integration of, we know that integral e power of ax sine bx dx equal to e power ax divided by a square plus b square a sine bx minus b cos bx. So we will have e power of what is, see, e power of minus st means a is minus s, x is t. So e power of minus st divided by what is a square minus s square plus b square is t square into what is a minus s sine t. Okay, actually e power of x sine bx means it is 1. It is 1. E power of minus s square and b is 1. A is minus s, b is 1. So it is 1 square into a is minus s sine t, then minus what is b, b value is 1 cos t, 1 cos t. So now we have to substitute the limits. Pi s, so the period is pi only, the period is pi, okay, the period is pi only. So we will have, so you have to be very careful while solving the problems, because here you are having p along with s, here you are having only p, so that you don't forget. So the limits are 0 to pi. The limits are 0 to pi. Okay. So this is the formula we have used now. See, by using this formula, by using this formula, we arrived at the above expression. So now take 1 by 1 minus e power of minus pi s into, if I substitute pi for t, I will have e power of minus pi s divided by s square plus 1 into minus s sine pi minus cos pi. This is upper limit. Okay, now minus lower limit, that is e power of 0 divided by s square plus 1 into minus s sine 0 minus cos 0. Okay, now write this is equal to 1 by 1 minus e power of minus pi s into e power of minus pi s divided by s square plus 1 into sin pi is 0 minus 1, okay, minus lower limit e power 0 is 1, so 1 divided by s square plus 1, cos 0 is 1, so sin 0 is 0, 0 minus 1. Now write 1 divided by 1 minus e power of minus pi s into, here you are having minus of minus s plus, so plus 1, here I am having minus, so minus e power of minus pi s divided by s square plus 1, okay, s square plus 1. Now you will have these two terms, but before cancel we have to check. Here you have to see sin pi, the value of sin pi is 0, value of cos pi is minus 1, so minus of minus 1, so it will become plus 1, so it will be 1 plus e power minus s, okay, because according to any strategy we are following in mathematics, we have to do with utmost carefulness, okay, because the expressions, they are called expressions because they can be expressed either in a right way or in a wrong way, okay, so it is our duty to check the expressions all the time, okay. So now take take 1 divided by s square plus 1 square into, this is can be written as 1 plus e power of minus pi s by 2 and again minus pi s by 2 divided by 1 minus e power of minus pi s by 2, then again you will have minus it is minus pi s by 2, okay, because e power of pi s can be written as e power of pi s by 2 plus pi s by 2, x can be written as x by 2 plus x by 2, okay. Now it can be a power m plus n can be written as a power of mn, so a power of m plus n can be written as a power m into a power n, so you will have 1 plus e power of minus pi s by 2 then into e power of minus pi s by 2 whole divided by 1 minus e power of minus pi s by 2 into e power of minus pi s by 2 into 1 by s square plus 1 by s square plus 1. Now you will have 1 plus e power of minus pi s by 2 divided by e power of pi s by 2 whole divided by 1 minus e power of minus pi s by 2 divided by e power of pi s by 2, okay, whole into 1 divided by s square plus 1, that is equal to e power of pi s by 2 plus e power of minus pi s by 2 whole divided by e power of pi s by 2 divided by e power of pi s by 2 minus e power of minus pi s by 2 divided by e power of pi s by 2, okay, into 1 divided by s square plus 1. Now the common denominators as a part of numerator and the denominator will get cancelled, so these two will get cancelled. So finally we will have 1 by s square plus 1 into e power of pi s by 2 plus e power of minus pi s by 2 divided by e power of pi s by 2 minus e power of minus pi s by 2, that is equal to 1 by s square plus 1 of the expression can be equated to cot h of pi s by 2, cot h of pi s by 2. Okay, now I shall give you the expressions. Kindly take it down. Sin hx. Okay, before that let us complete this solution. Okay, therefore L of modulus of sin t equal to 1 divided by s square plus 1 into cot h of pi s by 2. Okay, 1 by s square plus 1 of cot h of pi s by 2. Cot h of pi s by 2. Okay, I shall tell you the expressions now. Can you take down the expressions relating the exponential terms with the hyperbolic trigonometric terms? Can you take it down? Take down. C sin hx cos hx and tan hx. So this is e power of x minus e power of minus x by 2. This is positive e power of x plus e power of minus x divided by 2. This tan hx will be sin by cos, so e power x minus e power minus x divided by e power x plus e power minus x. So cosecant hx is inverse of sin hx, so 2 divided by e power x minus e power minus x. Secant hx equal to 2 divided by e power x plus e power minus x. Cot hx equal to e power x plus e power minus x, the reciprocal of tan hx, divided by e power x minus e power minus x. So these are the expressions. I hope you all understood the problem and the concept. So while solving the problem, you have to be very careful that whether you are doing all steps correctly or not, because a few mistake will make you to lose the entire mark for the problem. Okay, so you have to be very careful in solving all the problems. So thank you all for watching this video. I shall catch you in the next problem. Thank you.